Okay, so this is section 2.2, exercise 21, and you have the function sine of pi x, and the question is, what is the limit as x goes to 1 of the sine of pi x? And if you look at the graph of the sine wave looks like that. And as x approaches 1 from either side, the function is approaching 0. So all you have to write down is x equals 0.
So, like drawing the graph is the first step or the only step?
Well, in this case, the graph is drawn for you. And if this were the problem, and it doesn't say you must draw a graph, then drawing the graph is optional. If you think you need to do it, you do it. And if you don't, I mean, in a couple of lessons, you'll know that this is a continuous function. So the limit as x goes to 1 is just the value at 1, and the sine of pi is 0. So you get 0. But in this case, they're drawing the graph for you, and they're just telling you to look at the picture. So that's pretty easy.
I see. What about question number 49 from 1.2?
1.2?
Mhm.
Number 49. So
Yeah.
you want to find the equation of a line, and a point on the line is 1, 2, and you're told that the x-intercept is a0, and the y-intercept is 0a. So if you were to draw a picture of this, this is a and this is a. This is the line, but you also want that it goes through the point 1, 2. And it says, to make it a little bit easier, it says use the result of exercise 46. So if you wanted to do the problem using exercise 46, exercise 46 says that if you have a line where the x-intercept is a and the y-intercept is b, the equation is x over a plus y over b equals 1. So in this problem, the x and y intercepts are the same. So the equation is going to be the form x over a plus y over a equals 1. But you have to find a. And then you use the fact that the point 1, 2 is on the line. So when you let x equal 1, you get 1 over a. When you let y equal 2, you get 2 over a. So a has to satisfy this equation. And 1 plus 2 is 3. 3 over a is 1. So a is equal to 3. So the answer to this problem is x over 3 plus y over 3 equals 1. That's the equation of the line. And if you wanted to put it in sort of the standard form, you would say, okay, well, so y over 3 is 1 minus x over 3. So y is 3 minus x, which is another equation for the same line.
So is a is the slope?
Now, a is not the slope. This line has slope minus 1, right? You know, in point slope form, you might also write this as y is minus x plus 3. So the slope is -1 and the y-intercept is 3. The slope is -1. And you can see that from the picture. This is just a line with slope -1.
I see. Okay. Thank you. How did you get the rule of x over a plus y over a equals 1?
Well, the way I did that was I looked at the problem. The problem says use the result of exercise 46. Exercise 46 is this. It tells you that, in exercise 46, you're asked to prove this. It says that if A is the x-intercept and B is the y-intercept of a line, this is the equation of the line.
Okay, got it. Thank you.
See, another way you could have done this without using exercise 46 is, the equation of a line is y equals mx plus b, where this is the slope and this is the y-intercept. So in this case, we're told, let's see, what are we told? We're told that the y-intercept is a. So that means when x is 0, y is a. So y is going to be mx plus a. And we're also told that the point 1, 2 lies on the line. So 2 is equal to m times 1, that x equal 1 and y equal 2, plus a. So we have some relationship between m and a. And we're also told the x-intercept is a. And how do you get the x-intercept? When you let y equal 0, you get m times a plus b. So, which is m times a plus a, which is m plus 1 times a. So we're also given this equation. And if you have m plus 1 times a is 0, and 2 is equal to m plus a, then you're back to sort of high school algebra. You're solving two equations and two unknowns, and you can find m and a. But the easier way to do it is just to do what the problem says and use the fact that the line with x-intercept a and y-intercept b has the equation x over a plus y over b equals 1. So if you use this, you solve the problem very quickly.
I see. Got it. Thank you.
Okay.
If you don't mind, I also got 49 from 1.6.
Sorry, which
Yeah.
problem?
1.6,
Okay.
number 49.
Oh, well, so in 49, you just are being asked to match a function with the graph. So if you have the function, if you have the graph of y equals log x, that graph looks like that. And And if you have f of x is equal to the log of x minus 1, so this is the point 1. The log of x minus 1 shifts the graph 1 unit to the right. So for example, when x is 2, you get the log of 1, which is 0. And this is what the graph of the log of x minus 1 looks like. So you look and see which picture it is. And this picture number is picture A. When you look at the 4 choices.
And that's all I have to do, like in the paper for the homework.
But yes, yeah. The answer is A.
And for lesson 2, question 1 and 5, the first.
In which section?
5 questions. 2.2.
Okay.
Do you want us to show work for every part of the table, or
No.
just okay?
No. I mean,
it's a lot. That's why.
Yeah, no. Well, so you have to understand the syllabus is the department syllabus, and it was done with the idea that you do 2 lessons a week, but we do 2 lessons a day in the summer school.
Yeah.
So if you can do all the problems, that's fantastic. But I don't expect everyone or anyone to do all the problems. What I hope you will do is at least a few problems from each of the sections. So if you look at lesson 1, it covers sections 1.1, 1.2, 1.3, 1.6, and so on. So at least do some problems from each section. So you're learning a little bit of the techniques for everything that's on the syllabus. But again, but every day there's a big homework assignment in this course in summer school.
And we have other classes too.
Yeah, exactly. So you do as much as you can. I mean, somehow or other, you have to learn the work.
Yeah, of
How many
course.
classes are you taking in summer school?
I have other classes. One other class in this part of the summer, and a chemistry in the second part, July.
Oh, so that's a huge amount of work.
Yeah.
Yeah. But, you still have to learn the material. So it's not necessary to do every single problem, but you should do some problems from every section and enough problems that you think you understand what is being covered in the syllabus.
I see. Okay. And you advise us to learn the material from the book or sources from the internet, like YouTube?
Well, I have lectures for the entire course on YouTube already.
Yeah, but it's like this one, like you answer some question.
Well, no. So those are lectures when students are actually expected to be present on Zoom and can ask questions. But it still was a lecture where I cover all of the material.
Oh.
So students ask questions about homework or anything else, and I answer them. But I also am covering absolutely everything on the syllabus.
Throughout the questions of the students, right?
Yes.
Okay.
It's just like being in a classroom where the instructor is giving a lecture and students ask questions.
I get it, yes.
But everything, I mean, how you learn the material is up to you. If you can learn it from the book by yourself, that's great. If you watch the lectures, that's great. It's completely up to you. But you also have to understand that during the year, each class is an hour and 40 minutes, an hour and a half. So every So for lessons 1 and 2, that's 2 lectures, and that's 3 to 4 hours of lecture time. But it's no different from what would happen if this were being taught in summer school in class. In class in the summer, every class meets for more than 3 hours a day in the classroom. So no matter how you do it in summer school, it's a huge amount of work in a very short time.
Yeah, 3 weeks, I think.
4 weeks.
Like our final is July 1st.
Yes, exactly 4 weeks from today. Sorry, it's 4 weeks. The semester is exactly 4 weeks long. In the summer, a class meets every day, Monday, Tuesday, Wednesday, and Thursday, not on Friday. So it meets 4 times a week for 4 weeks, which means 16 classes. But the last day is the final.
Got it.
So it's exactly 4 weeks.
Okay, thank you so much for answering all my questions.
Oh, wait, someone else just is joining us. Interesting. Hello? Hello? Fatimata Dabo.
Hello, morning.
So I was just answering some questions about homework, and the part of these sessions is to answer questions and do homework problems. So if you have any questions, I am happy to try to solve them.
Okay, no problem. Thank you.
So again, I have 2 sessions a day for calculus, 9 o'clock and 4 and 3 o'clock. So if you're working on problems during the day, then I encourage you to come back at 3, and I'm happy to work them out as I had just done.